Hey guys, welcome to iCode. I am Pallav and this is the fourth part of our concurrency series, that is mastering concurrency in iOS. Before we start with this part, let's have a very quick recap of the things that we saw in the first three parts, starting with what is concurrency versus parallelism, the OS concepts like time slicing, context switching, how to achieve concurrency, what are the recommended ways of achieving multi-threading. Then we moved to GCD and we spent some good amount of time on understanding the concepts like task queue, thread pool, dispatch queues, serial versus concurrent, synchronous execution versus asynchronous execution. We understood main queue, global concurrent queues, quality of service, why it was needed. And then in the last video, we saw dispatch group, dispatch work items, what is the need of them and where can we use them. So today in this fourth part, we are going to wrap up GCD. This is going to be the last part for GCD, not for the series of course. In the next part, we'll be starting with the operation queues. But in today's video, we'll understand dispatch work item flags and to be specific, dispatch barrier. We'll see dispatch semaphores, a brief about dispatch sources, and then we'll wrap up GCD. So let's get started. So dispatch work item flags are basically the flags. They are the attributes through which we define the behavior of our dispatch work item. In the last video, we saw about dispatch work item, that what it is and where can we use it, for example, cancelling a task and those kind of things. But then if you want to define the behavior, for example, quality of service or those kind of things, we can use dispatch work item flags. So if we look at the syntax of the async method that we use with our queues, be it serial, be it concurrent, the async method takes certain parameters. So let's have a look at them, that what are those parameters. Now out of these four parameters, dispatch group is something that we know. We spent a good amount of time in understanding the dispatch group. Dispatch QoS is related to the quality of service, and that too we saw in detail. So dispatch QoS is also something that we know. The fourth one is the closure that will be executed asynchronously on the queue on which we are calling the async method. So there's not much to understand over there, which leaves us with the third parameter, that is dispatch work item flags. Let's see that what are those. So in total, there are 6 flags which can be used as the dispatch work item flags. These are the ones. And out of these 6, barrier is the one on which we will be focusing, because that is the one which is most useful of all. It doesn't mean that the rest 5 are useless. They do play a role in changing the priority, in changing the quality of service of the work item, of the queue on which it is being executed. But essentially, we do not change the quality of service or the priority while dealing with the problems like concurrency or the data inconsistency, the reader-writer problem, the race conditions. That is where the barrier flags come into the play. So we'll focus on the barrier flag. But before that, let's just have a very quick look on the first 5. So assign current context, set the attributes of the work item to match the attributes of the current execution context. While as an opposite to this, the detached work item disassociate the attributes of the work item from the current execution context. The third flag, that is enforced QoS, it enforces the quality of service of the work item over the quality of service of the current execution context. While as an opposite to this, the inherit QoS will inherit the quality of service set on the current execution context to the work item. And it is very clear from the name that if we set the flag to no QoS, no quality of service will be assigned to the work item. So that was a one-liner description about these flags, but essentially you will hardly come across any situation in which you will actually use these flags. These are very rarely used and I do not want to buy time on them. So let's move to the last flag, that is barrier, and that is most useful of all. So dispatch barrier is basically used in the scenarios where you want to control the access or where you want to avoid the race condition. So for example, consider this figure in which there's a concurrent queue. Task 1, 2 and 3 are being processed concurrently. Task 4 and 5 are also being concurrently, but there was a task in which you wanted the exclusive access. Basically, the idea was that no other task should be executed at the time when this particular task is being executed. So it is a kind of barrier. So essentially, the barrier flag causes the work item to act as a barrier when it is submitted to a concurrent queue. Because in the serial queue, the work items are anyway executed serially. But in the concurrent queue, when you want that your work item should be executed separately, the time when that particular item is being processed, the queue should not process any other items parallelly. In such scenarios, dispatch barrier flag is something that is of great use. And if it is not very clear from this theory, let's move to Xcode and let's see it in action. For understanding the barrier flag, let's continue the same example that we used for understanding dispatch group and dispatch work item. So till now in this example, we used dispatch group for making parallel API calls on splash screen, and then for checking the availability of the username, we use the dispatch work item for avoiding the unnecessary API calls. Now let's take it a notch ahead and let's see a use case which is perfect for understanding the barrier flags. Patrick Jane 07 was available, and let's say some password. Say Patrick. Now on this home screen, we see that we have two items which we can buy. One is the playlist for combined framework and the other one is the playlist for mock interviews. Each of them has a price associated with them, that is $30. And there's a button for buying the combo. And I'm considering that there's no discount on this combo. So which makes the total to $60 for $30 for the first playlist and $30 for the second one. So $60 will be the total amount that will be payable for buying this combo. And I see that in the wallet, there are $40 available. So assume that these $40 are some kind of onboarding bonus that the app has provided. And now before clicking on the buy combo, let's have a look at the code of this home view controller and let's try to predict, let's try to understand that what is going to happen. So this is the UI related stuff which I'm not going to explain. It is pretty much self-explanatory. And then we are having a concurrent queue here for purchasing the items. The attribute is concurrent, so we can see that the queue is concurrent. Then we have an array of products. This is the action method which will be triggered on tapping the buy combo button. Now what is actually happening in this method is that we are iterating over the array, that is this products array, and for each item we are calling a function that is add items to cart in an asynchronous fashion on our concurrent queue. So the purchase queue is the concurrent queue, and then we are calling this method add items to cart from this concurrent queue in an asynchronous fashion, and we are passing the product while iterating on the products array. Now let's see that what is happening in this add items to cart. So we pass the product to it, and then there's a check that if the wallet balance is greater than the price of the product, then only proceed, otherwise show some other payment options. So basically the if condition is going to redeem the amount available in the wallet, and if the wallet is not having the sufficient balance, then we are going to tell the user that you do not have the sufficient balance, please use some other payment options for making the purchase because we cannot redeem the amount from your wallet. So that makes sense. And within the if block, we are calling this method buy product of the purchase manager. So this can be any method of network layer or maybe any kind of asynchronous execution. And we are passing this closure. So this will be executed once the execution of this buy product method will be completed. So what we are trying to simulate here is that for each product, we are going to make an API call. And once the server responds, then we are going to change something in the wallet balance and in the cart value depending on the response. So if the purchase of that particular product is successful, we are reducing the price of that product from the wallet balance because now that much amount has been used in buying that product. And we are increasing the cart value because now that is in cart. In reality, in actual projects, this is not how it is done. There's a very elegant and very graceful way of dealing the things. But here, just for simulating the use case for the barrier flag, I have done all this. So now let's see that what will happen if we tap on the buy combo button. So let's go here, and if I tap on buy combo, I see that the cart value changes to $60 while the balance in the wallet changes to -20. Now this should not have ideally happened because we are having a check here for the wallet balance that if the product price is greater than wallet balance, then show payment options. I mean, this statement should get printed in the logs. But this didn't happen if we check the logs, and that is because the value of wallet balance was not reduced with the first product's price, and meanwhile the second iteration of the loop got executed. So if we take it slowly, if we try to understand it, we iterated on this array of products which was having two products and each of them was having a price 30. We called the add items to cart method asynchronously on our purchase queue. Now because the operations are being executed asynchronously, till the time we got the response from the server, that is this closure got executed and the wallet balance was reduced, before that the purchase of the second product was actually executed, and hence this check failed here. The if condition for checking that if the wallet balance is greater than product price, then only proceed with this flow, otherwise show the show payment options. So after the first purchase, if we reduce $30 from the wallet balance, that is 40, it should have been $10, which is less than the price of the next product, that is $30. But in this case, the wallet balance was not actually reduced till the time the purchase for second product got executed. So for second purchase too, the value of the wallet balance was $60, which is greater than the price of the product, that is $30, and hence this got executed. As a result, we see that the wallet balance is now -$20 and the cart total is $60. Now let's try to fix this using the dispatch barrier. Now before using the barrier flag for solving this, let's try to find out the piece of code. Let's try to find out that block to which we want to allow the exclusive access. So this add items to cart would be the method to which we would like to restrict the access. What I mean is that if one purchase will be in process, we will not allow any other queue or any other thread to enter this particular block of code for executing the next purchase. Basically, we are going to create a barrier. So when this block of code, when this item will be executed by the queue will not entertain any other work items. Let's say that how can we do that? And it is really simple to do, because we saw that the asynchronous method takes the flags, and one of the flags is barrier. So if I try to write here purchase queue dot async, and the one in which we can pass the flags as barrier, and in the execute, if I write the same block of code here, it should be weak self because we are accessing the self in the closure. So let's try to, and if we give it a run, so this is for Patrick Jane 07 Patrick, and just sign up. We see that the wallet balance is $40. The price of the combo will be $60, and let's clear the logs and let's click on the buy combo button. We see that the cart total is $30, wallet balance is $10, that is 40 minus 30, that is $10. And for the second product, we got our statement printed, that is show payment options. So this way we created a barrier, and by creating the barrier, we solved the race condition that was happening here. This particular property was being accessed by two threads at the same time, and both of them were writing it. The value was changing, and hence this if condition, this check of ours was failing. So the data inconsistency that we were facing, that we solved using the barrier flag. Now for dealing such problems, there's one more way, that is dispatch semaphores. Let's have a look at them. Semaphores is another one of the brilliant ways to deal with the problems of race conditions, the data inconsistency related issues, the access to the critical section. We'll see that what is a critical section and how semaphores work in a minute. But before that, let's take an example to understand the use case of the semaphores. So let's assume that there's a bank and there's a joint account in this bank. So joint account is a kind of account which has multiple account holders for the same account. Now because there are multiple account holders, they can have multiple debit cards, and all of those debit cards can be used for withdrawing the amount from the same account. So assume that two account holders of the same joint account, if they try to withdraw some amount from two different ATM machines, maybe if they try for withdrawing the amount at exactly same point of time, and if the bank is not having the handling for these kind of concurrent transactions, what can it lead to? And similar to our previous example, there would have been some check that if the withdrawal amount is greater than balance, let's not proceed with the flow. But because both of them accessed it at the same point of time, both of them will get the cash. So this is exactly the same problem that we solved using dispatch barrier. And hence it is very obvious to get the doubt that if dispatch barrier is there, what is the need of dispatch semaphore? Or what is the extra benefit that semaphores offer over the barriers? Indeed, semaphores are more powerful and they provide more control, more customization when it comes to deal with the race conditions or those kind of situations. But for understanding that, let's see that how semaphores work. So this entire mess of data inconsistency related issues, it starts with critical section. Now, critical section is basically a part of program which tries to access some shared resource. And when that critical section is accessed by multiple threads, multiple queues at the same point of time, then there are strong chances of data inconsistency. So in the example that we saw before this, the method add to cart, that was a critical section because it was changing the value of wallet property, which was a shared resource. And because this critical section was being accessed by multiple threads at the same time, we faced the problem of the race condition, the reader-writer problem, the data inconsistency and everything else. So the solution is to get the exclusive access. For that particular critical section, we should have exclusive access so that if the data, if that shared resource is changed by one thread, the other one gets the updated value. It's always atomic. And here comes semaphores as the saviors. So assume that this is a critical section. And let's say that three threads are trying to access it at same point of time. Now, if we use semaphores, how it will work is that it will have a threads queue. All the threads who want to access this critical section, they will be added to this queue and one thread will be allowed at a time. So to control this, it will have a counter value. Now this counter value can be set to any particular value, be it 1, 2. Now here comes the difference with dispatch barriers. So when we were using dispatch barrier, we were kind of creating a barrier. that for this particular duration nothing else should be executed. But in case of semaphores, we can even customize it, we can control it, that if we want two threads to access it at the same time, we can do that. You would be thinking that why would you do so? Well, there are scenarios like that. So let's say that you want to download say 50 images, but you do not want to download more than 5 images at a time. So in this case, the critical section that is related to the downloading or maybe the saving of your images, you are fine with the behavior that 5 threads can access it at one point of time, but the 6th one should not be allowed. So in that case, what you can actually do is you can set this counter value to 5. This will actually control the 5 concurrent access to your critical section. As soon as the 6th one will try, it will have to wait. So let's see that how it works. The counter value has been set to 1 in this case. Now when the first thread will try to access it, it will come and it will call the method wait on the object of the dispatch semaphore. As soon as the wait will be called, the counter value will be changed to 0. And as per the implementation of the semaphores, the access to the critical section is allowed only if the value of the counter is a non-negative integer. So in this case, the value of the counter is 0, which is a non-negative integer, and hence the access will be provided. If at the same time another thread tries to access it, as soon as it will call the wait function, this value will be reduced to -1, and because it is a negative integer, the access will be restricted. So once the job of this particular thread will be done, it will call the signal method. The signal method will increment the counter value by 1. So this will again change to 1. The next thread waiting into the queue will get the access. The wait method will be called again, and as soon as the wait method will be called, the value of the counter will be reduced by 1. So now it will change to 0. Now because it has been changed to 0, the next thread waiting into the queue cannot access this critical section unless this particular thread will leave it. So once this thread will be done with its execution, the signal method will be called again. It will increment the counter value by 1, and then the next thread waiting into the queue will get the chance. This is how it works. So essentially there are two important functions here, that is wait and signal. Wait decrements the value of the counter by 1 and signal increments it by 1. This way the threads queue and the exclusive access is managed. So semaphores is one of the ways to deal with the problems that comes with multi-threading, and it provides us great control, but at the same time we should take care of something, and that is priority inversion. So in layman terms, by priority inversion, what I mean is that your high priority task should not keep on waiting for the access to the critical section, because low priority tasks access them first and then the semaphores came into the play, and now the high priority tasks are waiting for the access. This should not happen. Well, this is not actually priority inversion. For priority inversion to take place, there should be a third task which would be of medium priority, and then the 3 tasks of 3 different priorities, that is low, medium and high, will be executed in such a way that the high priority task will keep on waiting for the access to the critical section. So I'll mention the link in the description in case you want to read about the priority inversion in detail. I'm not taking it up in detail because I want to focus on semaphores. Priority inversion is something related to the scheduling algorithms and how the OS works with scheduling of the jobs, while we want to focus on GCD here, but I'll mention the link just in case you want to read about it. Now this entire working of semaphores would have appeared very easy to you, that it's just about calling a wait and the signal method, but you would be thinking that is it really that easy? There would be some hidden concepts or some other complexities involved. Well, actually there's not. So let's jump to Xcode and let's try to solve the same problem that we solved with barrier using the semaphores. So in the same function where we use the barrier flag, let's remove it. Let's give it a run with the previous implementation just to see if we are getting the 60 as the cart value and -20 as the wallet one, and then we'll fix it using semaphores. So if I click sign up here, and then if I click buy combo, we'll see 60 as the cart total and -20 as the Patrick, because this is our critical section, essentially this one, and this is being accessed by 2 threads at same point of time. So let's restrict the access. Let's control it using the semaphores. Let semaphore, that is a dispatch semaphore, is equal to dispatch semaphore, and while initialization we can give a control value. So for now I'm giving it 1, and let's use the wait and signal method. So here I'll use semaphore dot wait and self dot semaphore dot signal. Instead of this wait function, you can use the other variation also, which takes a timeout duration. So you can see that the same variations of the wait function are available here that we used with the dispatch group. So that works the same way, and here we are using wait for holding the access, and then we are calling the signal for again incrementing the counter value so that the next thread can access it. And now let's just give it a run. Let's clear the logs. And now if I click on buy combo, we see that the card total is 30, wallet balance is 10, show payment options got printed. So this is because the access to the critical section was restricted using the semaphores, the wait and the signal methods, and it is as simple as that. So that was about dispatch semaphores. Now more or less we have covered almost everything related to GCD except one, that is dispatch sources. Now dispatch sources is something which can be used for listening to the events from the system. For example, memory usage status, or maybe kernel signals, or periodic notifications. Basically listening to the notifications, the data that system triggers. Now this is again one of those rarely used things which you will hardly come across, or you would ever feel the need of it. So I do not want to stretch the video by going into the details of dispatch sources. It's just that something that can be used for listening to the events that are being triggered by system. Now where can we use it? Well, there are actually some use cases of it. If you'll go in detail, you will find some candidates using dispatch sources. For example, an editor application where you want to know if the status of the file has changed, if it has been renamed, or if it has been moved to some other location. So these kind of notifications from the system can be listened by dispatch sources. Or if you want to deal with those kind of tricky interview questions, that how can you run a timer on the background thread? Because for a timer you need an active run loop, and in case of background queues you may or may not get it. But in case of main queue, there's an assurity that you will always get it. But if interviewer tells you to build a timer that should run on a background queue, dispatch sources is something that you can use. And we will go through this question in detail in the last part of this video series that will entirely focus on the interview questions related to concurrency. But for now, I think that you should not focus much on the dispatch sources because that is something which we rarely use. But yeah, we should know about that, what is a dispatch source and where can we use it. So that brings up to the end of the GCD module of this concurrency series. From next video we'll be starting with the operation queues, and later in the series we'll also see the actors, the async await, the latest in concurrency. That's pretty much about this video. If you like my content, if you like my videos, you can consider subscribing to the channel. Let's write better code together. Happy coding, stay safe.